Hi everyone, my name is Federica Virla. I'm a PhD student at the University of Verona, and today I will talk to you about my PhD project entitled Extracellular Vesicles from Stem Cells, a therapeutic tool for neurodegenerative diseases. My interest and my studies are mainly focused on the basic research in the field of motor dysfunction and neurodegenerative diseases, in particular amyotrophic lateral sclerosis, ALS. Like other neurodegenerative pathologies, ALS is a very complex one because it can be due to several and different causes. It is highly disabling and it affects thousands of people in the world. Up to now, there is still no effective cure for ALS. To counteract the motor neuron loss typical of ALS, by the way, motor neurons are located in the spinal cords and they are the cells that let you move your muscles. Several scientists have demonstrated the neuroprotective effect of stem cells of the adipose tissue. But using stem cells can be a bit tricky and results are not always the one that you expected. So in our lab, we focused on the extracellular vesicles that are round structures released by stem cells because they are easier to use and they recapitulate the effect of their origin cells. You can imagine extracellular vesicle like social media app of cells. In fact, stem cells use vesicles to communicate with other cells, sending them neuroprotective molecules, in this case, and good vibes. So once we obtain extracellular vesicles, we test them in different laboratory models that can mimic ALS conditions. The first one is a simple cellular model of motor neurons damaged with a toxic agent. The second one is a more complex mouse model that shows neurodegeneration and motor defects, similarly to ALS symptoms. The results we obtain confirm the neuroprotective action of extracellular vesicle from stem cells. What we observed in the intracellular model was a higher number of living motor neurons when we treated them with extracellular vesicles. Regarding the mouse model, we observe an amelioration in their motor performances and a higher number of motor neurons in their spinal cord after intranasal injection of extracellular vesicles. The importance of our basic research is to collect more information and knowledge as possible to translate one day to humans. In fact, the use of extracellular vesicle from stem cells is a promising tool to contrast the neurodegenerative diseases like ALS. However, the treatment with extracellular vesicle in our mouse model wasn't sufficient to ameliorate the survival of these animals. For this and many other reasons, it is very important for scientists to keep on studying and researching. If this presentation intrigues you, you have some questions or you need more information, don't hesitate to contact me at my email address and I will be pleased to answer you. Thank you for your attention.